Okay, thanks everybody for joining us today. We might as well get started. We're a few minutes past scheduled kickoff time, so welcome to our webinar, jointly brought to you by C.R.Kennedy and BricsCAD on surface modelling and concrete checking. So we're going to try and cover a little bit here in terms of the capabilities of that we have within BricsCAD and that we are now sharing to our clients across the country in Australia through C.R.Kennedy. So, I had a look through the list of registrations that was sent through. Looks like there was about 120, 130 registrations, which is fantastic, from all over Australia. So it's great to see a lot of our existing clients and a lot of potential new ones as well showing interest in what we've got to offer here. So we've got a couple of special presenters, but before we go to them, Sam, I'll do a quick overview of C.R.Kennedy for those who don't know. C.R.Kennedy is a family-owned company, been around for over 90 years and started out many years ago as the importer of Pentax cameras. So long history in importing highly specified technical equipment and optical equipment. So and in my time at C.R.Kennedy, the last 20 odd years, we've been the exclusive distributors for Leica Geosystems survey equipment, and that's effectively the Rolls Royce of measuring technology accepted. I think that's accepted worldwide. That Leica have led the way for many years. So you might have seen, for those who aren't in the survey game, surveyors on the side of the road, they're generally using a Leica total station for doing their measure ups, and lately the main products have been the TS16. You would see perhaps if you're in construction, the ICR 70, and if you're in the interior trades, you would have seen the ICS 50, a new product for the interior trades in fit out and joinery, etc. We'll also be releasing, or it's been announced, but there will be a brand new TS20 total station that will be even more advanced, and we'll have some road shows on that coming up later in the year. So very exciting times within Leica. We've also, you would have seen the point cloud capabilities that are produced by our scanners. So the BLK 360 and the RTC 360 is very popular in spatial sciences and data capture. So and that's only just scraping the surface of what CRK do. We've got multiple other products and solutions. And one of those solutions is BricsCAD, obviously brought to us by BricsCAD, and their ability to work with our equipment and with the data sets that are produced by our, particularly the scanners and the survey instruments as well. So whether you want to produce a drawing file, a point cloud file, or just a straight up points file, BricsCAD can manage everything through those data formats to produce plans and models of any description. So that's well, BricsCAD. We've just to recap a little bit on that, our involvement with BricsCAD. We joined a partnership with them around about 3 years ago, 2.5, 3 years ago now. And C.R.Kennedy had always been looking for a product that helps us complete the solution, all very well capturing data and measuring data in the field, but what did we do with it once we're back in the office? Not so much us, but our clients. So now in the last few years, we feel that having access to one of the more advanced CAD products in the world with BricsCAD, that we now complete that loop, and we have a full solution available for all our clients. So to tell you a little bit more about what we're talking about today, we've got two presenters. From C.R.Kennedy, we've got Vasily. He joined us about a year and a bit ago now. He did his surveying degree actually over in Perth, and funnily enough, it looks like he was always predestined to work for C.R.Kennedy, because in 2013 he won the C.R.Kennedy and Co. Surveying Prize for the highest first-year achiever in the course. So that set Vas on the path to CRK, I reckon. He did his sort of groundwork years in WA, and then moved to Vic, worked with Ready Surveys for a while, really learnt the ropes about doing feature and topographic surveys, re-estabs and the like. And then after that, he progressed to work with some big national clients of ours, very big players in the spatial game in Veris and land surveys. So with lots of project management experience, coordinating field parties, working with other project managers and liaising with clients, really got stuck into the technology across the board and honed his skills in CAD. So he's a very well-rounded professional in our game. So there's we can learn a lot from Vass today, hopefully. And from the BricsCAD side, another relative newcomer to our world, I guess, not necessarily in the CAD space, Sam McAllister. He's only been with BricsCAD, I think, 6 months or so, and in that short time, he's already proved invaluable to us at C.R.Kennedy with his knowledge and his ability for support and, helping not only us but our clients take the leap from not having CAD at all or being involved in another CAD product that they're not overly happy with, whether it be price or capabilities, and converting them to BricsCAD. Sam, he's got a good history. I mean, he's presented at Autodesk University in the States, so he's obviously well regarded in that environment. And he's now even been doing some part-time tutoring at the University of Technology in Sydney, so helping students develop practical design skills and to meet industry standards and the like. So Sam brings a lot of experience. Vass certainly does as well. So without any further ado, they're going to take us through the webinar today. So I think now, Sam, I think we'll start off with Vass. Is that correct? Okay, thank you.
Thanks for that, Bernie. Let me just get set up here and start sharing my screen. Just a moment. Cool, there's the infinite scroll that everyone can see. Right, so thank you for the introduction, Bernie. I believe I don't need to cover too much about what C.R.Kennedy does. The only thing I'll add to it, I suppose, is that we're the largest supplier of equipment, and I suppose now as well training across Australia for measuring equipment and cameras and all sorts of stuff. I'll try to make this presentation relevant to both newcomers to CAD and survey professionals that are used to working with CAD data and spatial data and delivering that sort of product to an end client. However, bear with me those that are used to doing all this, because I'm sure it'll be a bit, you'll be a bit used to doing this in the past anyway, so you'll know a bit of this. What I'm hoping to end this presentation with is that everyone here will have a good idea of how you can get started with surface modeling in BricsCAD. So hopefully after today, with this webinar recorded, you could open up a copy of BricsCAD, use whatever tools you have on hand, and create yourself a surface model that is useful to either your project or your end client. So with that in mind, we talk a lot about high-end technology, but you can perform the work that we're going to show you with nothing but a long tape measure and an optical level, if you want to do it that way. And I know a lot of TAFEs in sort of first year uni will teach that sort of process. So that's relevant, and that's the same sort of process you would use if you had flat 2D data in CAD and wanted to turn that into 3D surface models as well. That said, BricsCAD can handle point clouds, can handle laser scanning data and generate very similar outcomes. And Sam will go through that after I go through the basics. And most importantly, I suppose, because this is a webinar that we're attending during work time, we all work with this sort of data, whether we're using it for our own sake or whether we're delivering it to an end user. The reason that we should actually care about it, I suppose, is because, especially in my role now, I'm finding it's invaluable, this ability to assess a slab or a surface or anything for modern methods of construction. So more and more is being built off-site and being expected to fit exactly right first time on site. The classic examples of that would be any sorts of steel or prefabricated housing, data centers. We'll get into that a bit more, I suppose. As well, this is a good opportunity for, if you're on the construction side, to become an innovator, where you start using these tools in-house to accelerate your ability to deliver quality projects. So for hardware, the data set we'll be looking at today was captured with the Leica ICR70. So that's a robotic total station. You would have seen a surveyor on the street before, I suppose, like with the tripod. And I think many of you as well would have experienced using this in the past as well. Beyond that, we'll see some data from the RTC 360. So both the total station and the RTC 360 were used to map a section of slab in a commercial warehouse here in Victoria. It wasn't done for a delivery. It's just a bit of a test data set. So hopefully the surveyors in the audience don't judge me too harshly for my methods. From either of the devices, a laser scanner or otherwise, you would require some data output from that. So in the case of a total station, you would output a DXF or a points file as a CSV. Then if you're using a laser scanner, you would output a point cloud file in a LAS or E57 or recap file. Then down to the very nitty gritty, you can as well perform this with pen and paper if you need to. So you can see on the right a little teaser of what we're going to get into. In terms of choosing the right tool for your project, again, there's a broad range. It's horses for courses, as they say. In this instance, we're doing I think it was maybe 30 by 30 section of slab in a commercial warehouse. It would be appropriate to either use a total station or a scanner for that. The biggest difference, I suppose, besides time and money, is the resolution of the data. Resolution means how often am I mapping the environment. So with the total station, you can see my sort of grid of points that I made in my awkward stumble, probably about 4 meters by 3 meters or so. Whereas with a laser scanner, you would be able to capture data, in a 1 by 1 millimeter grid if you were so desperate. And if you have any questions on hardware, applications, use cases, etc., that is what we do. So give us a shout, we'll grab coffee, talk about it, and try to point you in the right direction. And software-wise, why should we look at BricsCAD for doing this? So I've got experience doing concrete heat maps and I suppose topographical surveys, volumetric surveys, and that line of work. There are products out there that do this. However, the methodology to do this in BricsCAD is incredibly easy, and it bundles in as a CAD product, so you can easily create a PDF or standard DWG deliverable for your client. Do you need a big, powerful computer to do it? Probably not. So if you're using traditional survey technology, very light files, lightweight files, they'll get taken in and processed rapidly. If you're taking in scan data and point cloud data, it's quite likely you do have a powerful computer already, but if you don't, you are able to what's called decimate or thin the cloud to make it usable for your purposes on a weaker computer. And as mentioned, you can export this data in a typical CAD format or a PDF plan as necessary as a deliverable. Because it's a CAD program, you're able to overlay other plans together and provide a very quick assessment of whether or not your project is meeting the design criteria. I think I got a little carried away with the last point as to who can use this, but this is a list of sort of typical clients that I've worked with lately that have expressed to me that this sort of workflow and this data is very relevant to them. And yeah, as you can see, anyone that's building anything on a presumably level surface or a design surface needs to be able to, with certainty, ensure that the design is met prior to installing what their construction project requires. So without further ado, I've prepared a data set and sort of workflow that I'll put on the screen now, and after which I'll jump in with some more tips, tricks, workflows, and we'll take questions as we go. We'll get to answering the questions at the very end of this. So yeah, just put your questions in if you have anything. So just jumping into my video that I closed already. And I might just do a quick check with a thumbs up when I play it, make sure everyone can hear. Where are we? So Sam, in a second, if you give me a thumbs up on this. All right, he's moved his hands. Excellent. Sorry,
That's on the wrong screen.
It's on the wrong screen? Yeah, 1 second, I'll put it back on.
First up, open DLVG. And I've got my BricsCAD to show me the Civil Survey suite there. So you got Civil Explorer, tin surface options, points and strings, alignments, road corridors, adding labels, which is super useful, data imports, and some of these for manual survey calculations. So we've got our data in here. It's a series of points with elevations. You can't really see the point there. You can see that it exists. To see the point, we can go into DDP type and go into here, change it to maybe a plus, circle, maybe 0.25 size. Close it. Now we can see all of our points. Next up, it's always good to check the units. Let's go in here, check we're in meters, in case we're in some funny unit from data that we're not aware of. Now we're going to use the tin surface button to turn this to a surface for concrete evaluation. So I might make layer here, plus tin, get into my layer there, and we'll just make a tin surface. Cool. So it's a wireframe surface at the moment. We can change that to modeled surface over here. Like that. You can't really see what's going on yet, but we can enable a few more features. So we can go civil, tin surface, get a lot of options over here. Might turn off the triangles, turn on the elevations. So this is a really good start. So we've got 2D triangles, range interval of 10, number of ranges 25. So we can change this up a bit to make it look a little bit nicer. Just smooths it out a little bit. We're able to also change above and below datum. So if we wanted to have a cutoff point for a minimum level, we could do that. But I'm happy with this for now. The only other thing I might do is turn on the contours. So go on, and our minor contour can be 0.05. Major contour 0.01. Cool. So that's every 5 millimeters, we've got a minor. Every 0.1 meters, 10 millimeters, we've got a major. Maybe to make it stand out a little bit more, we can put the majors in magenta, the minors in blue. And there we have it. So we can see our contours here. That makes sense. It's about 280, 279. That's rounded, by the way, so it actually goes to more decimal places. It's 28283. Cool. We're pretty happy with that. Maybe next we want to do some labels. So we can go up here and go add surface labels. And we want to do contour labels. Default, it's fine. Let's select our surface. Maybe we'll just put it through like that. So it will look like this, which is really ugly. That doesn't really help us very much. So instead, we can go into our settings, and go into label style, and change the default. So in here, we can click components and check out what goes into it. Maybe we'll change the size to 0.35 meters. And we'll edit the contents. So we'll first want it to say precision. It's down to the millimeter. And maybe we'll add the M suffix to it. So it'll look like this. Go OK. There's a lot of other options we can play with, such as background mask, which is handy for us. But we'll leave it for now. Okay, cool. There's our label. It's a little bit big for my taste, so maybe we'll go edit and just change the background mask again. That's looking pretty good. So you can start seeing your low points there, 8269.
Cool, welcome back to reality. So that's the one that I prepared earlier on screen for us now. And hopefully the way that I presented that to you guys, I took no shortcuts in how the data is assembled. So I know a lot of you won't have any default settings for any of your labels or colors or anything like that. In the recording of this video, you can probably slow it down, check step by step where you go to investigate all of those settings. But yeah, with this information, you should be able to provide a deliverable like this pretty quickly. Now, the other feature I wanted to get into for surface evaluation beyond just checking the high and lows is checking cutoff elevations. So in this case, I've selected my tin surface on the left here, and we've currently got our colors set by number of ranges. What's quite useful to have is actually the range interval with datum. So an example of where this would matter is, of course, a flood-prone area if you're meeting a certain level for the slab to be above, or perhaps it's whether you need the slab to be very, very flat for a high-precision work where you need to either fill, pack, or grind the slab to meet a certain requirement. So in this instance, I've selected range interval with datum. I've said that things above our datum, so above a value we select, are going to be in red, and things below that datum are going to be in hydro or blue. I've chosen 2D triangles, and most importantly, I've put the datum as 8.275 as our design level. So this can be changed, of course, to suit your data, and it can be changed pretty easily on the fly. Just to show you, put it in, it changes. Hopefully, this is getting across the point that it is really easy to get started with this and to get some serious insights from your data very, very quickly. Beyond this, a little bit beyond the scope of this webinar, which we might do in a future one, is going over some of the additional survey functionality in this top row here. Specifically, something that I would value that's potentially a more advanced use is the use of strings and civil strings and civil points, because you're able to take these elements. So whether you've traced, let's say, the edge of a building or a road, or from some aerial photograph on something, you can trace that, place it over here, and it'll drape it in 3D to that surface to match the levels. So beyond that, I'd say the only other one worth showing for this deliverable is probably adding your surface labels for your spot heights, because my drunken stumble is not a very pretty grid, but I can improve that by going add surface labels, just gotta hide this, and go spot elevation, default, select my surface, and probably select the grid there. My grid's gonna start in this corner. Your grid spacing is maybe 2 meters by 2 meters. Set my grid rotation, and then set the size of my grid, and voila. So it's a little bit offset there, but what it's done is created for us this grid of points at a 2 by 2 meter interval. So this could be more useful to a site crew wishing to grind or pack or fill or screed to a grid, as opposed to our sort of stumble of points. Just as a showcase before I pass to Sam as well, just showing this sort of work in 3D. So here it's the same surface. I've just manually added some lines in 3 dimensions. You can see there, just to illustrate the fact that you can, again, engineering surveyors here are going to tell me, yeah, I've been doing this for years, but a lot of people aren't aware that you can create all of this stuff in 3D in CAD and work with it and manipulate it without having to necessarily use survey equipment in the field. And lastly, as a bonus little feature, I wasn't super aware of the fact that you can go into a lot of these little buttons here and investigate some of the extra features. We've got the water drop, where if we select our surface and we put our cursor on the surface there, it'll show you that line, and that line simulates what would happen were you to have a rainfall event, or water drop in this case, and where that water would go on site. So that is relevant for environmental monitoring. It also looks cool. And one very last bonus feature is mapping a image to a surface. So this could be reverse engineering how you do your drone work, where if you have a very accurate surface model from traditional survey means or laser scanning, you can apply an image to that surface like this. If anyone does something like this for their own work and gets paid for it, I'd be very impressed. But here's my image in a JPEG that I've mapped to a varied version of this surface. Right, so I think I'm going to pass to Sam to do some more of the advanced capabilities, if that's okay. And yeah, we'll go through your questions at the end.
Great, thanks so much, Vass. So, is it coming through? Okay, so I'm just going to pause for a second. Jin has some polling questions, which she's going to put up on the screen right now, just before I get started. It will just take a couple of seconds. It's just to sort of understand what your interests are, why you're here, just so we can get a bit of background. So if you can cast your vote, and let us know what industry you're from and perhaps what current software you're using. That'll be great insight for us to perhaps understand where you're from and what you use. Give it a couple more seconds. Okay. All right, so if we can stop the poll, I'll move into the presentation.
Sam, I'm yet to launch the second questions from the
okay.
majority coming from surveyor.
Okay, sorry, I jumped the gun.
Yes, I'm going to launch the second questions right now.
Thank you. Yeah, so the next question is to do with the software. So thank you for completing the first one on industry. And we're very keen to hear what type of software you use for your civil and surveying space. Great to see a lot of BricsCAD users out there.
Shout out to the BricsCAD homies.
Okay, fantastic. We're okay to proceed, Jen?
Sure.
Excellent. So thank you so much for doing the polling questions. I'll be taking over some of the workflows inside of BricsCAD 2025, and at the end, we'll be just showcasing where you can register for a 2026 release coming out on the 21st. As mentioned, my name is Samuel McAllister. I'm the Senior Solutions Consultant at Brixis. First of all, to get started, Brixis, BricsCAD, Hexagon, what's the difference? So Hexagon owns a number of companies, Brixis and BricsCAD being one of them, but they also supply laser scanners. So they've got incredible technology for providing point cloud scans that work with its own software technology. Hence why if you bring in large point clouds into BricsCAD, it will process them very quickly. BricsCAD's not just effective for doing that, it's got other tools, which we'll cover a little bit on today, but basically it will give you all the flavors of CAD, but it will also integrate with other Hexagon-based products. It was founded in Belgium, part of the Hexagon family, headquartered out of Sweden. We provide the software in 13 languages. It's in 90 countries. We have 400 resellers, and half of that goes back into R&D. It's called the True CAD Alternative, as it does provide 2D and 3D CAD that works or competes against other CAD vendors. It's familiar, so if you migrate from your CAD authoring tool into the BricsCAD environment, you'll find the user interface and the functionality very similar. It works on one single design platform. You don't need to import and export file formats. You can do it all within this one solution. We're also bringing in some AI productivity tools. So these tools will make you more efficient in your workflows in the CAD environment. We provide several different licensing options. So if you want to buy the product and own that product forever, you're entitled to do so with a flexible licensing option from BricsCAD. We have an open approach working with IFCs and CAD formats. We also have a very good support team. So any problems, you can log supports and you're going to get something back within 24 hours with an answer. And of course, the price, it's a big game changer. You can get this at a cost-effective price. You can own it under that flexible licensing options and use it forever. It comes in 4 different flavors. There is an Ultimate, which holds everything, but the 4 that you'll get in the Ultimate, which you can buy separately, is the BricsCAD Lite. What to note here is you do get Lisp functionality in the Lite version of this CAD tool. BricsCAD Pro, which is probably our most popular version of BricsCAD, especially in the civil and surveying space, because it's got all those features. You can bring in all these different tools to write your own APIs, and numerous third-party plugins that will work in other CAD platforms work inside of BricsCAD Pro. We also have a BricsCAD BIM. This is a solid 3D DWG modeling environment. It's not a BIM like a Revit, for example, but it does work with IFCs. You can bring in RVT files should you want to. And finally, we have BricsCAD Mechanical. So this will be working for 2D and 3D users. It's efficient for doing its detailing, but you can also work to create assemblies of parts. You can annotate your views and do your bill of materials. So if we look at 2 different CAD platforms here, you'll notice they look pretty similar. Similar ribbon interface, similar drop-down menus. However, if you look at what's different, in the BricsCAD environment here, there are productivity tools, drawing health tools, dedicated civil GIS tools, and 3D modeling tools. And what these will enable you to do is to go through and do a drawing health check. You can also use tools like Copy Guide to automate copy commands around your project, Move Guide, and manipulation. And there's some smart tools like Blockify and Parametric Blockify, which will go and grab similar entities in your model and then create blocks out of those entities that match. Moving into some of the tin surface creation options here. So we're going to touch on some of the ones that Vas mentioned just before. One is just importing it from text files or CSV files. You've got a dedicated Civil Explorer panel here where you can do the drop down and you can look at different ways to create boundaries or add raster images to your surfaces. You can create that tin surface from 1 or multiple files. So we're going to do a video demo bringing in multiple text files. You can also control how you want that file format to be comma delimited. And you can adjust this information as you work with it inside of BricsCAD. So here, typically with most programs, you start with the ribbon going from left to right. So we're going to create a tin surface by importing from file. We're going to choose the point file format. There's options here and how you want to see that information. We'll bring in those dozen or so text files and import them. Create the tin. And now we have a 3D model coming in. It's just asking us whether we want to simplify it, enter the elevation number. And here we have those points creating a tin surface for us. Now, here in the file, we also have a raster image and a closed polyline for the boundary. So we want to look at adding that boundary to the tin surface. So it takes us through the options here in our command line. I've got a little pop-up here that I've customized inside of BricsCAD, but you can always also use the command line down the bottom. So you can choose that boundary, choose how you want that boundary to form. So it's going to take out the outer part of that boundary. And now we have that tin surface clipped to the boundary. Next here in the drop down, we've got the surfaces where we want to choose a raster image. So simply choose the raster image, choose the destination, and now it will map that raster or drape that raster over that surface. And here in our selection hierarchy, we can turn off that raster image. So a really simple workflow to generate a tin surface with a boundary with an image. Land XML is one of the simplest ways to bring in the data. So when you do bring it in, it's going to hold different data inside it. So your tin surface, your alignments, vertical alignments, 2D and 3D. It's just a simple workflow. In your Home tab, import the Land XML, choose the XML file, and this will automatically convert it to a tin surface, but you'll see it's contained the alignments as well. So a lot of data is held in that Land XML. And so here with our alignment projected horizontally in the 2D plane, but draped and following the path of the imported tin, we can also do a vertical cut through it. So here we get a plan. We've got our vertical cut showing through that alignment, and we can select it. So anything in the generated in the model, we can go to our properties, our layers, and we can make adjustments to, say, the vertical scale factor to see how that alignment runs. If you're a Civil 3D user, you can also import Civil 3D natively into the BricsCAD environment. So it will work with all these different types of points, point groups, tin surfaces, volume surfaces, grid surface and alignments. It will come through and convert that into different sections. And you'll see how clean it is when it comes in and how you can reuse that data. So all we're doing is, again, going to the Import Export tab, bring in that Civil 3D created DWG. Here we can look at what we want to bring in. Maybe you don't want to bring in everything, but we're going to bring in all that and then choose how we want to bring in the civil data. And here we have 60 native CAD entities imported. Our contours, our alignments, our text files, all the layers are available. And here in our Civil Explorer, we can see the data that it's brought in, grouped and set out there in the hierarchy. Also, you'll see you can adjust information on your major and minor contours as well. So not only can you bring in this data and it's all organized, you can also work with this data as well. Tin from contours, really simple. You just need to bring in your contours, or if you've got 2D contours, you can move them up in the Z direction if needed. There's a weeding and supplementing factor should you want to use that, and this will simply just create your tin surface. So again, very simple. Whenever you hit that tin surface command, it gives you all these different options on how to create it. You can choose certain entities or all entities. We've got 42 contours in this file. We don't need to use any of these particular tools. We just want to keep it quite simple at the moment. And now we have a surface. This is just showing in 2D wireframe. We've got numerous different ways of displaying that information. But you can see here now it's created our tin surface. Our contour lines are maintained. But when we select that tin surface, we can see that there's information about the contours, which we can change. And also there's some information about tin analysis for elevations and slopes, which you can potentially turn on. Finally, one of the really powerful features is creating a tin from point cloud data. So it will work with really large files. When we get to the surface deviation tool, we're working with a data set that's about 33 gigs. So it handles heavy data. I'm just working off a basic Dell laptop. You can simplify the data as you bring it in, or you can even go to parts of the tin surface and make it more detailed by using the Densify tool. So this is some of the files I've been referencing in. They have processed, but once they're processed, you can then bring in that file and it will display as a scan surface here. We can go to the color map and look at how we want it to display. There are numerous things you can do here. You can choose the different type of color scheme, the intensity ramp, adjust all the colors as required. As per the other workflows, just hit the tin surface, choose what you're creating that tin from, grab the point cloud, and then it will give you the option, should you want to simplify it, we'll go yes, doesn't need to be too dense. And then there's a radius for what you want to use for simplification. So 10 by default is fine, and then 5 for the elevation difference. And now we have our tin surface. So we just go back to the structure and just hide the imported laser scan. And now we have a tin surface from that laser scan. So simple and quick. Now moving into the building space, into validating what's happening with the surfaces, or maybe a BIM or ISC model inside of point clouds, we can bring in really large point cloud files, and it's going to handle really well inside of the BricsCAD environment. It will process the data instantly. The heavy files will load really quickly and then convert. And once we work with the design intent model and the laser scan, it will produce a heat map on any 2D horizontal or vertical alignment surface. So you can work with surfaces, or you can work with IFC or BIM data. It will still look at those surfaces and produce the heat map. And the tolerances are really easy to adjust here. It's very intuitive and simple to use. Now, if you're using a tool like an AutoCAD, that won't natively bring in those raw laser scans. So you need to go to something like BricsCAD Pro to process it. Then it will spit out an RCP or an RCS, and it will bring in up to 25 million points. The power of BricsCAD is that you can bring in all these file formats natively. It will process it quickly, and it holds up to 50 million points. So it's very strong when it comes to managing point cloud data. In this demo here, we have an IFC model, and we have our referenced 33 gigabyte laser scan. We're just going to insert it at its central location. Again, you can set this all up accurately if you want to put in your georeference information. Here, we'll just go to view inside the model. So we're doing the whole model here, but we can do a deviation of this particular slab and the point cloud. And now you'll see how quickly it's processed it. We can look at the acceptable tolerance. So drop it down to 0.006 of a meter, change the warning tolerance to 0.012, and we can see where we are with our scan versus the design intent model and how far we might be out. Now, if you want to do something even simpler, you don't need to be in a forced camera view. You can just go and choose maybe part of the model you want to look at. So here we're just going to save view, where we have, say, a section cutaway. We're just looking at a particular floor that we might have scanned. We can do that as well. We can just break down that IFC model, isolate that floor, and we can do the deviation scan, not on the entire drawing, but we can just choose parts of the drawing. So if you want to do this really quickly, maybe you don't have a decent laptop, you can just do those two entities and run that deviation scanner. And by default, it's the tolerance, the good fit tolerance and the bad fit tolerance are quite high here. So again, it's just as simple as making adjustments to see how smooth that poured slab is that we've obtained with our scan. Now, if you don't have the BIM data to go through this, you can just do something really simple with a surface plane. So here we have a scan that vasted, and if you just want to create an automated flat plane, let's say you know nothing about CAD, nothing about BIM, you just want to do something really basic, you've got some simple tools here like Fit Planner, and this will go and search for a dense part of the point cloud and then create a flat surface almost aligned with that point cloud. And then you can start to look at what your tolerances are. So I did drop the tolerances down quite a bit here just to sort of show the scan versus the slab, but it's just a really simple, quick and easy way to run that deviation analysis tool. So hopefully you've got something to take away from creating tin surfaces and doing deviation analysis. So our key takeaways for you today is that with these type of tools, you can be faster and more efficient on your project work. You don't need to rework a lot of information or take into other softwares and then process it in and out. For anybody who is new to CAD, maybe you're just in a subtrade construction, this could be a very simple tool to get on board with. You don't need to go into different softwares. You can just do a lot of simple jobs in one software platform. And the price and the licensing is very simple. You can get it at a very affordable price. You can own it forever, or you can keep it on perpetual and maintenance and keep on getting updates, getting new features, but we give you those options. Now, if anybody is attending Melbourne Build next week and want to perhaps discuss some of the things that Vas and I have shown today in a bit more detail, we will both be at the C.R.Kennedy booth. So please come by and say hi. If you want to, we have a QR code on the screen. So if you want to hold your phone up over the screen, we can facilitate a time to actually meet with you and go over some stuff in detail. So for anybody in Melbourne next week, it'll be on the 22nd and 23rd of October. A huge show. They do one in Sydney as well. But the C.R.Kennedy team will have some equipment. We'll be there with some software. So we encourage you guys to attend if you're going to be in Melbourne or live in Melbourne. And for anybody wanting to know when the launch of V26 is of BricsCAD, it is next week. So it will be Tuesday, the 21st of October. And you can register for free. We'll have updates on general design, manufacturing tools, but more importantly, what we talked about today, there'll be new features for building subcontractors and land surveyors. So please be sure to register for the digital event and you'll be able to see what's new in the V26 launch. With that, we'll open up the floor to Q&A.
Yeah, I saw some questions pop up already. We'll try to address them in order, I guess. The first question I see on the list was by Ayad, asking about the transparency. Can you change the transparency? If so, how for point clouds and BricsCAD? I actually haven't got one on my computer right now to pull up, but the answer is yeah, you can. You select the point cloud, and there is a transparency setting for the layout or for the point cloud, I believe. Sam, is that correct?
Yeah. There's so in the color display, there's a number of different ways you can change how the point cloud displays. So maybe while you're going through the questions, I can bring something up in the background.
No worries. Then Arthur is asking some direction for setting up the workspace with all the point cloud and modeling tabs. If you've got BricsCAD Pro and you just select the civil or survey module to start with, you'll have a lot of your tabs preset at the top in the way that they should be. However, you may have clicked by default to be in 2D drafting mode or another type of design mode, I suppose. To resolve that, I think I'll add it to the list of things that Sam can show on screen, perhaps. But more or less the solution is we just need to get you to restart the software and select civil survey, I suppose, to get a nice set of tools at the top.
Yeah, down the bottom right here are all the features. So if you need to bring up more tools, so what you'll see here, if we look at point clouds in particular, I'm in the civil survey space, and so here are the tools available. But if I switch to the building information modeling space, it will load up a lot more point cloud tools. And you can see over here, there's a number of different menus here in the tool palettes. And so going back to the other question, which was just looking at the point cloud information here. So let me just hide that one. So here with that point cloud selected, we can go to our so we've got our render settings. There's two things to bring up here. You've got render settings, and so this will just bring up information about classifying data in the point clouds. That's probably a whole nother topic, and I would encourage you to check out the 2026 version coming out. There's going to be a lot more features for doing that. And then we have different things here for our render settings. So there's some nice little tools like gap filling. And this is a pretty big data set, so it's doing it pretty quick. You've got iDome lighting. Typically, you drop that down a little bit just so it makes it a little bit lighter, and then you can adjust the point size. And so this will, go up and down pretty fast. Depending on the type of scan, you'll have adaptive display and dollhouse rendering, but this one didn't have that information in it. We also have over here the color map, and this is where you have the option to do different things with the style. And I think this one maybe doesn't have all the features available in it. Here we go. So we've got elevation, for example. We can start to make some changes with that data. But maybe with this one, I may have to look for another data set because there's an X-ray feature, and I think that would refer to what there is. Sorry. So I don't know if that sort of helps answer the question a little bit. Yeah.
As well, just to jump in, I'm pretty sure you can also just change the layer transparency settings for the point cloud. So as in just going to layers, selecting the layer that's on and changing the transparency. You might have the transparency tab turned off there, but yeah.
Okay.
I think you would right click the top and add. It's all right. Doing it live is, yeah. Well, but the answer is, you can definitely do it.
Yeah.
What was the next question? Let me have a look. Up next, Imran is asking, will we be showing the grading tools today? Unfortunately, no. That's probably a bit more advanced than this webinar is going to offer, but we are taking comments and questions to prepare, follow-ups and additional sort of webinars like this that are, outcomes focused. So if you have a type of project or workflow that you're looking for to get some advice on us, to share with people how you work and get back and forth, then give us a shout, give us some feedback, and we'll try and prepare another one. Then Tim Langford's asking, when you're making the surface tin, do you have to have civil points or can they be any points? The answer is, you can have any points, so you can come from civil points or just a CSV of points. You can come from faces of triangles. You can come from contours. You can come from a point cloud. Yes, I think the underlying question might be, how do you import points into BricsCAD? And correct me if I'm wrong, but I also sort of, it was a bit convoluted for me when I first started. But if that's the question, we can go through that as well separately. Then Tim Hinkley is asking, when coloring surfaces by elevations, is there a way to retrieve or set specific color values for within a legend or on a plan? I'll be honest, I actually don't know the answer to this question directly. Sam, have you got experience? Have you tried setting a legend automatically from the surface elevation map?
No, but what we could do, perhaps, if it wants to email me, my email address is on the screen. I can just check that one on my teammates.
Yeah, we'll go through it. So I'm not aware of automation for that right now. I'm aware of how I would do it if I was to custom script it, but I'm not sure if there's out of the box automation for it. I'll have to check. And then Justin Waterhouse is saying that he's a civil contractor and he's looking to do some CAD work himself, or rather turn CAD provided to him into 3D surface models for what I assume to be machine control files. Yeah, the answer to that question is, yeah, this is a typical way of doing it through BricsCAD. So you'd be provided that 2D file, you would open it up, it would all be flat. And whilst a little bit laborious, you will have to go through and associate heights with everything as you need, or perhaps even design your own sort of grades as you need. So the answer is, yeah, you can do it through BricsCAD and you can export an XML for a machine control file. Then Tom Fitz is asking, is there an equivalent to edit point datum in BricsCAD to easily adjust heights of datum sets? Is it easy to merge two data sets together, rotating the datums and combining a jigger and GPS? So as a surveyor, my answer to this is I actually don't know what edit point datum is, but I definitely have and still continue to align data both in 2D and 3D in BricsCAD. The tools that I use to do that are the align tool, which is more or less picking 3 points for shift, rotation, and scale if you need to. You can do it in a few different ways, and I think this is one of those things where every survey company I've worked for and every surveyor I've worked with has their own their own rules and methods for doing this. So the answer is, yeah, you can do it. If you want to talk about how we do it, then perhaps, yeah, we can take some time together and go through what I do and what I've seen other people do. That, I think, is the questions in the Q&A. What else we got? Let me have a look. What have we got there? So David Samuelson is asking, importing point clouds and manipulating them to align to existing data. It's a good question. I'll be honest, I haven't done too much of it in BricsCAD Direct. Sam, were you aligning the point cloud to the data or the data to the point cloud in this case?
Sorry, can you repeat the question again? Sorry.
The question is, how would you go about aligning point cloud data to existing data, or vice versa, existing data to point cloud data? So I could answer that from aligning data to a point cloud, but I actually haven't manipulated a point cloud to realign it very much. I know there's tools for it, but I haven't done it very much.
Okay, because yeah, when you go to insert it, it will ask for insertion points. So if you know where you need to insert it to,
okay, so you do it directly. Yeah, but in terms of referencing it through targets or common features, it's an additional workflow, I'd say.
Yeah. Again, it's probably something we could find out. So if they want to email me, I can reach out to our internal teams and get an answer for that one.
So yeah, my answer is that you can do it. I have a way of doing it, but I think if we wanted to put out a polished webinar on how to do it, that would be a separate matter. The way that I do it at the moment, I've had to do it, is just through, again, the move and rotate tools and go point by point. But then, yeah, we'll probably refer to Gopi as to what he would suggest. I think that's pretty much it. If anyone has any other questions, then don't stress emailing us, I suppose. If there's a specific workflow that you're looking for, because as a surveyor, a lot of this CAD stuff doesn't really, you don't learn this through university, you learn this through working and sort of getting breadcrumbs from lots of different people. So we're more than happy to set up some more sessions tending to specific workflows. Hopefully we can sort of build a better understanding and better standard of practice for the industry if we get the questions out. Yeah, thank you everyone, I suppose. Any closing thoughts, Sam or Bernie?
Please feel free to fill out the survey so that we will know what kind of topics that you would like us to cover in the future. Thank you.
Yeah, and if we missed anybody, just feel free to drop us an email and we'll do our best to get back to you. So yeah, thank you so much for all the questions and attending. And Bernie, any last things to close us out?
No, I just want to thank you two guys for a wonderful presentation. As Vass alluded to, there's it was really just touching or scraping the surface. Probably opened up a can of worms of many other capabilities that BricsCAD has. So we'll endeavour to address your upcoming questions and things, but also we'll endeavour to run other events like this, webinars and the like. So by all means, everybody keep an eye and an ear out for future marketing on various events that we'll be running. But of course, the immediate event is Melbourne Build next week, as has been mentioned. I think that'll be a fantastic opportunity to come to our stand and see Sam and Vass and the other guys